Okay, so notes on the Pythagorean theorem. Pythagorean theorem, honestly, guys, is one of the most useful things that we can learn in mathematics. Okay, so I use the Pythagorean theorem because I teach math, but in my everyday life, outside of being a math teacher, I actually use this the most of anything that I've learned in math. I use this every single time that I line off a football field. I use the Pythagorean theorem. When you are trying to make a right angle, like a lot of times people that tile floors or tile like a bathroom, like a wall potentially, you would use the Pythagorean theorem often in that. A roofer, right, making like a triangle portion of a roof, might use the Pythagorean theorem to make those the wood pieces to be at a right angle. Okay, so a lot of different applications for this Pythagorean theorem. You've probably learned about this. A guy named Pythagoras came up with the theorem, and he found that for right triangles, so this only works for right triangles. We have three different right triangles drawn right here. Okay, those are all right triangles. So even though this one's facing left, that doesn't mean it's a left triangle. Okay, they're all called right triangles because this angle in the corner, all right, is 90 degrees, which is called a right angle. So all of these are right triangles. Pythagorean theorem works for those. And the Pythagorean theorem says that a squared plus b squared is equal to c squared. Okay? And A and B and C are sides of the right triangle. So we got to identify a few things about that. So A and B are what's called the legs of the triangle. Okay, they make the L portion of the triangle. So A and B would be those two. C is your biggest side right there. So on this one, again, A and B, it really doesn't matter where they go. Okay, they could be in opposite order as well. But C is the thing that matters the most. So A and B and C. C, it has a special name. All right. C is what's called the hypotenuse. All right, it's the hypotenuse. And it's the biggest side of your right triangle. Okay, it's the side that is always opposite from this right angle. So if there's your box, the corner box, C is going to be right across from that. So that longest side is going to be always across from the 90-degree angle because that's the biggest angle in the right triangle. So it's going to have the biggest opening between the two, all right, for the biggest angle. So we have our three parts. We have A, we have B, we have C. And what we're going to do with the Pythagorean theorem that we're working towards is we're going to work towards finding a missing side. So we might be given the hypotenuse and we got to figure out one of the legs. Or we might be given the legs and we might have to find the hypotenuse. Okay? All kinds of applications with these, with word problems. Like could be a ladder leaned up on a house. Could be building like a ramp, okay, maybe up to a building, right, to make it accessible. Could be that we're building like some kind of slope, right, a slope in maybe on the road. Could be the ground is sloped, right, up to a building, whatever, right, all kind of applications right here for right triangles, okay. So the first thing we're going to look at is Pythagorean triples. So these are numbers that make the right triangles all the time. They make the Pythagorean theorem true. So your first set is 3, 4, and 5. 3, 4, and 5 is the most basic of our Pythagorean triples. So 3 is your A, 4 is B, 5 is C. 5 is the biggest number, so it has to be my C value. So if we plug that into our Pythagorean theorem, a squared plus b squared equals c squared. Okay. So we have 3 squared plus 4 squared equals c squared, 5 squared. Okay, so a little bit of a review for you guys. All right, kind of maybe a little thought bubble over here. What does it mean to square something? So, for example, 3 squared is 3 times 3, which is 9.
Oh, you can explain that bottom quick.
4 squared is 4 times 4, which is 16. Okay, so all we've done so far is we said 3 is a, so we took a squared, which is 3 squared. Okay, 4 is b squared is 4 squared, right there. And then c is 5, c squared is 5 squared. So now all we're doing is we're proving the Pythagorean theorem true right here. So 3 squared is 9, 4 squared is 16, and 5 squared, 5 times 5 is 25. Okay, if you actually add 9 and 16 together, you get 25. And 25 is equal to 25, so we have proven the Pythagorean theorem true. So that means that if you have any triangle that has side length 3, side length 4, and side length 5, that triangle is going to be a right triangle. So that means that we guarantee that this angle right here actually is a right angle. Same for 6, 8, and 10. Which makes sense because all we did was double all the sides, right? So doesn't mean that we do anything to the angles. The angles can all be the same. So if you want to work that one out, you can, right? 6 squared plus 8 squared is going to give you 10 squared. That's 36 and 64, which does add up to be 10 squared is 100. Okay, that one actually adds up too, and it's good. All right, it makes the Pythagorean theorem true. So I actually use this as a football coach. I use the Pythagorean theorem when I square off the football field. So when you have a grass practice field that you have to paint the lines of the field on the grass, we have to make sure that the field is a rectangle, right? You have 90-degree angles in the corners of a rectangle. And how do I guarantee that something's 90 degrees if I don't have anything that's already made out, like a template for that 90-degree angle, right? Well, I use a little bit of math and some measuring tape, and I'm good. So all we do when I make the corner of the field is we start in a corner, and we'll measure out 3 feet one way. We'll put a little tick mark, okay? And then we measure 4 feet down the sideline, put another tick mark, and then I measure in between the tick marks, okay, that distance. And that distance, if it's right at 5 between those two markings, all right, if it is 5 feet, that tells me right now that we have a right angle in the corner. So my field is going to be squared off, okay? It's going to have a 90-degree corner, which is what you want. Because if you think about a football field, even if you're off just a little bit, like if I'm at like 91 degrees or something, that 1 degree over time is going to make a huge difference, right? The further I go down the field. And nobody wants a field that looks like that, right? You want a field that's a perfect rectangle, okay? You can't have your field being longer in some areas than others. It's got to be uniform, right? It's got to be correct. So that math really matters for the field. Okay, does that make sense so far? All right, so what we're going to do is next we're going to look at a couple examples. We're going to find the missing side length right here. And what I've done on this side, this is just some review of some information for us. All right, we found and wrote down all of these are called perfect squares. Perfect squares. Okay. So, for example, like 1 squared, 1 times 1 is 1, right? 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25. 6 times 6 is 36. 7 times 7 is 49. 8 times 8 is 64. 9 times 9 is 81. 10 times 10 is 100. 11 times 11 is 121. 12 times 12 is 144. Okay, so these things, this kind of funny symbol right here, may have seen this before, may have not. This is called the square root. All right, anytime you take the square root of a number, you get some number out. So these numbers are perfect. So if I take the square root of 9, it's going to give me a nice whole number on the other side. So square root of 9 is just 3, right? The square root of 25 is 5. And some numbers are perfect squares, some are not. For example, if you have one that's like the square root of 11. So you see how square root of 11 is in between 9 and 16? Right? It falls in between those perfect squares. So it's going to be a little bit, it's going to be closer to 3, but it's 3 point something. All right, if you look at the decimal of that, the square root of 11, I'm going to type that in my calculator. It's actually 3.317. Okay, which makes sense. It's in between 3 and 4 because 11 is in between 16 and 9. So that's just a little bit of review on the square roots on these perfect squares. We're going to kind of need that information as we go and we solve some of these problems. All right, so let's look at number 1. Number 1 is a right triangle. I know that it's a right triangle because they give me this square box in the corner. That tells me that that's 90 degrees. So since I have a right triangle, I know that I'm dealing with the Pythagorean theorem. Okay? So I know that I can use the Pythagorean theorem to find a missing side length. All right, let me zoom in here so we can see. All right, so here's our first example. What I want y'all to do first, and as you get good at this process, you don't have to go through this and write all this down every time. But here in the early stages, I think it's helpful to write out what your A is, what your B is, and what your C is. Okay? So C is the most important. My corner box, C is always directly across from that corner box, across from the right angle. So C is going to be X. All right, so that's the most important piece of information that we can find. So we have A is that, C is my X, and B is 5. And again, A and B don't really matter. I could have said 5 and 12 or 12 and 5 like we did here. Okay, so we're going to plug this into our Pythagorean theorem to find the missing side length. A squared plus B squared equals C squared. So we have A squared, that's 12 squared, plus B squared is 5 squared, equals C squared. All right? And I keep putting C, this is actually X squared for us in this problem. Okay?
We already read it out. Like, the C is supposed to be the answer between A squared and B squared.
So 12 squared is 144. 12 times 12. Plus 5 times 5 is 25. And that's equal to X squared. So if you add 144 and 25, we get 169 is equal to X squared. And so I want to know X times X is equal to 169. So the same number times itself is going to be equal to 169. Well, you can find this by taking the square root of this. So the square root of, like 4 is just 2 squared, right? And the square root of 4 is 2. 9 is 3 squared, right? The square root of 9 is 3. So you can undo the squared by taking the square root of the number. So if we type this into our calculator, the square root of 169, you're going to get that X is equal to 13. So X is equal to 13. So as I'm going through this, as I'm checking myself, I know that C has to be the longest side, right? So I'm checking. This side's 12, that's one of the legs. This side is 5, that's one of the legs. C is 13. Is 13 the longest of the three sides? It is. Okay, as long as I get something that's longest of the three for my C, then I know that I've done it. All right, I have a pretty good indication that I've done it correctly. All right, let's look at number 2. So here's 2. Now we have a little bit difference in this problem. So let's find C first. So C is 20. Very good. All right, so C is 20. That means A is 12 and B is X. Okay, so this time we're actually going to be looking for one of those legs, not the hypotenuse of the right triangle. So A squared, that's 12 squared. B squared is X squared equals C squared is 20 squared. So we're going through and just writing down what we have. 12 squared is 144 plus X squared. And 20 squared, 20 times 20 is 400. Okay? So at this point, we're going back to what we learned about with solving equations. I'm going to need to move this 144 over to the other side by subtracting 144. So subtracting 144 from both sides. That's going to isolate my X squared by itself. It's going to get those to cancel. 400 minus 144 is a 256. And when we take the square root of that to get X by itself, we get 16. Okay, so X is equal to 16. So again, I can go back and ask myself, does my answer make sense? Did the answer that I get for the leg, it was 16. I know that needs to be less than the hypotenuse, which is 20. 20 is got to be the biggest side. So if I worked everything out and I got an answer that was like 22 point something or something else, right? Maybe I added these two together, 144 and 400, and I took the square root of that, which is 544. Well, that's going to give me 23.3. So if I get 23.3 for one of these legs in the triangle, I know I've done something wrong because C has to be the longest side. Okay, so kind of a short way to think about this. If you're looking for the hypotenuse, you add. If you're looking for one of the legs, you're going to have to subtract somewhere in the problem. Okay, let's look at one more. We got one more example. This one's a word problem. I know we love word problems. Okay, so Garrett is using a ladder to climb on the roof. Okay. The ladder is 5 feet from the base of the house, and the ladder is 20 feet tall. So we may be asking ourselves, how tall is the roof? Right? And so we have this is actually a bad picture. This would not be getting us to the roof, would it? This is only getting me to the window. Let's redraw my picture. All right, so here, let's say, that's my house. There's the roof. Okay. So we're drawing a picture. A lot of times a picture helps with a word problem. And then we got to decode what that word problem's saying. So the ladder is 5 feet from the base of the house. So that's saying it's like 5 feet away from the house is where I set the ladder and lean it up against the house. So 5 feet is going to represent that distance right there. So we're going to label our 5 feet there. And it says the ladder is how long? 20 feet tall. So the ladder is 20 feet. Well, that's the slanted portion. And we want to know how tall the house is, right? How far it is to get to the roof. So That's going to be this side. So how tall it is to get up to the roof. So that's your X. Well, hopefully my house has been built correctly and we have a 90-degree angle here. Hopefully, right? If it's built correctly. So we have this kind of triangle. We have...
So 20 feet is C.
20 is my hypotenuse. Yep. 5 is my A or B. And we're looking for X, right? So this is going to be 5 squared plus X squared equals 20 squared. 5 squared, 5 times 5 is 25 plus X squared. 20 squared is 400. So looking for B, we're going to subtract. So we're subtracting 25 from both sides. We get X squared equals 375. And our last step is to take the square root of both of those. So the square root of X squared is just X. Square root of 375 is 19.3649. So we're just going to say 36. Okay? 19.36. Does my answer make sense? 19.36 is smaller than 20, right? 20 has to be the longest side because it's the hypotenuse. So how tall is the roof? It's 19.36 feet.